Hello, my name is Elizabeth Jones, and this is my final project presentation for ADTA 5940, the Analytics Capstone Experience for the Spring 2023 session. This is a study on weather and date impact on United States public transportation, property damage, and injuries. This presentation will cover the project report, including these 6 key areas. The United States Department of Transportation supports America's needs for an economic, safe, and reliable transportation system. Several transportation modes are available in the United States, with many Americans using public transit made possible with federal funds. Work trends are transitioning to spend more days in the office, and the population is increasing in the U.S., with density and ridership in urban settings relying more on transit infrastructure and services, leading to rising safety concerns. Travelers heading home from work may not be aware of safety issues as a part of their daily commute. For example, does the weather have an impact on safety conditions that result in safety events? Are there months or days that are more susceptible to safety events? This study explores public transportation major safety events. 2 research questions are the focus of this study. The first question is, do environmental factors affect or determine the occurrence of property damage? The main outcome of a major safety event is the dollar amount of property damage resulting from the incident. Exploration of climate factors may reveal patterns and serve as a baseline as climate change becomes a more prevalent topic. Weather types will be the input variable. The second question is, do time factors affect or determine the occurrence of injuries? Injury occurrence is the target variable, and the input variables are month and day of week. Understanding trends in date factors can identify generalizations of when major safety events occur. The literature review explored a variety of public transportation topics. New York City is the top public transportation hub in the United States, with commuters in 2021 completing nearly 760 million subway trips and 312 million bus trips. One study used card reader data in Bayesian origin destination estimation to predict future subway usage rates. Research in 2021 focused on accident prediction in the weather-diverse area of Chattanooga, Tennessee, by using a multi-layer perceptron neural network to predict locations and times of future incidents. Research in 2018 used deep learning with weather and traffic data from the state of Iowa to predict accidents. The data in Iowa was considered optimal due to a variety of weather patterns in the state. 2021 research explored how passenger safety is influenced by bus driver actions, such as the rate of acceleration, frequency of quick acceleration and deceleration, and quantity of long stops. Ferry transportation demand has decreased in the most recent 3 decades, yet underfunded marine infrastructure has historically been an issue that has sidelined progress and is a potential target for high property damage claims. Passenger rail has experienced more than a 33% increase in ridership, yet there continues to be several safety incidents that occur in rail transit. Research in 2022 used image data from traffic cameras to identify adverse weather conditions and pavement condition with convolutional neural networks. The research used 3 weather condition labels and 3 road surface labels to predict current driving conditions. A similar study in 2020 used image data and deep learning to detect foggy weather and to inform commuters of potentially dangerous driving conditions by labeling images with 3 levels of visibility. A subway study in New York City looked at usage based on several weather factors and concluded that evening ridership has the most disruption due to weather changes and morning trips have the least variance. Also, rain and snow that occurs on weekends rather than weekdays creates more transportation schedule instability. From 2010 through 2013, there were $77 million in additional maintenance costs due to weather damage to train tracks. Climate change issues cause disruption to public transportation by damaging transit networks, increasing costs, and reducing passenger system reliability. As climate change continues to gradually intensify, it is probable that the occurrence of injuries and property damage will rise. Let's transition to the current study where data preparation utilized Microsoft Excel for viewing and preparing the data, and data visualizations were prepared with Tableau desktop software. Analysis for this study uses the Major Safety Events dataset provided by the United States Department of Transportation. This data is updated in the first few days of each month and is part of the National Transit Database that serves as a data repository for United States transportation information. Here's a small sample of the data for this project, which was exported as a comma-separated values file on April 14th, 2023, and consists of 78,330 rows of observations with 101 columns of variables. Another way to conceptualize the data is this illustration, where each square represents one variable with 49 discrete fields, 2 continuous, and 50 nominal fields. The original data source includes years of 2014 through 2022. This project will only use the most current full 5 years of 2018 through 2022, resulting in 44,337 rows of data remaining. Also, there are 101 variables in the dataset, providing opportunity to simplify the data by removing variables that are not useful for analysis, leaving just 17 variables remaining. For use as perspective, a secondary dataset that is also provided by the U.S. Department of Transportation provides the overall total of public transportation ridership in comparison to major safety events. Here's a look at the fields in that dataset, and here's a combined summary of the major safety events dataset and the overall ridership dataset, showing that property damage and injuries per trip are at minor values. There's also a significant increase in property damage per trip, doubling in more recent years, while the total passenger trips were at lower counts. Although associating the major safety events to the large overall quantity of public transportation trips is small, there remains a 5-year total of nearly $314 million of property damage and close to 45,000 injuries that occurred over the course of 35 billion passenger trips. Additionally, the reputation and trust that riders have for public transportation are based on the results of minimal safety events. During the exploratory data analysis phase of the project, Microsoft Excel and Python with the Anaconda Navigator and Jupyter Notebook were leveraged to explore the data. Tableau desktop software was also used for data visualization. There are 2 numeric response variables in this analysis: property damage and total injuries. Property damage indicates the dollar amount of damage that was incurred for each major safety event, and total injuries conveys the count of individuals that experienced physical harm during a major safety event. We're looking at the statistics summary for the response variables, with 44,337 records with average property damage of $9,666, and number of average injuries is at 1.01. The standard deviation measures how spread out the data is around the mean, with the dispersion of property damage at $47,194 around the mean, and total injuries dispersing at 1.23 around the mean. Property damage occurs with a wide range from a minimum of 0 to a maximum of $7,250,000. Total injuries has a range of 0 to 27. Here's another view of the response variables by year, showing property damage with a yearly average of $63 million and increasing totals year over year, except for 2020. Total injuries also reflect a decrease in 2020, increasing in following years. There are 2 date-time variables of incident time and incident date in the dataset. This view shows the count of incidents by hour, with the years indicated as a separate line on the graph. Most incidents occur during work commuting hours between 6 a.m. and 8 p.m. Here's a graph of property damage and total injuries by hour, also with the most incidents occurring during work commuting hours. Property damage is higher in the mornings, and total injuries are higher in the afternoon hours. The modeling phase of the project utilized Python with the Anaconda Navigator and Jupyter Notebook. The major safety events dataset was split for the modeling process into two subsets, with 70% of the data for training and 30% for testing. The first part of modeling involved evaluating the first research question. The target variable of property damage is continuous and will be evaluated with the categorical input variable of weather that contains 8 different weather types. The model will use multiple linear regression to identify the linear relationship of the target variable and the inputs. After building the model and training it, the coefficients for each weather option are seen here. Here's another output with the weather type names and coefficients listed. These coefficients are also referred to as weights that are important for determining predictions in the model based on the inputs. In other words, each of the weather types indicate how strong the relationship is in the model. In this model, each type has a similar large negative number, and the model may be overfitting. The R-squared value in the model provides a measure that shows the amount of variance in the outcome that the input variables provide in linear regression. This picture shows the R-squared value from the model at a very small number that rounds up to 1%. This value indicates how well the independent values predict the dependent value of property damage, and the model is performing poorly. Additionally, k-fold cross-validation of the model was performed to measure the model's performance. The outcome is pictured and suggests there is a high error rate and that the predictions from the model are not accurate. The second model addresses the second research question. Input variables will be the month and day of week in a multiple linear regression to identify the linear relationship with injury occurrence. The model provides these coefficients for each of the 18 independent date types. After fitting the model, the coefficient for each variable is indicating overfitting. The model also has an R-squared value very close to 0, meaning that the independent variables are not doing a good job of predicting the number of injuries based on the date information. The k-fold cross-validation for the model performance has a high error rate, indicating the model predictions will not give accurate results. The goal of this project was to analyze 2 research questions. After leveraging weather variables in a multiple linear regression model, the results conclude that only using weather factors are not a reliable method of determining property damage amounts. For the second question, inputting date factors into a model to identify if the date will predict the number of injuries does not provide reliable prediction results based on month and day of the week. Although the results from both research questions did not provide actionable results, applications of identifying contributing factors that predict property damage and injuries could be of interest to several entities. Insurance providers would be a key industry that could use prediction information to adjust insurance coverage based on models that accurately predict the possibility of accidents based on the date. Another application could be for emergency and medical care providers, to be able to prepare for injury scenarios. Additionally, local governments may be interested in predictions from the data to facilitate risk planning. There are several limitations to consider in this study of major safety events in mass transit. Several variables from the original Major Safety Events dataset were excluded from this analysis that could be used for further research. For example, the incident description field is a free-form text field that could be used for topic modeling to find underlying incident themes or for keyword extraction and text classification. Future research could include classification of variables in the dataset. For example, classifying property damage levels as minimal, medium, and maximum may find better results with the use of a decision tree for prediction. This future research could be useful to the Federal Emergency Management Agency, or FEMA, for deploying faster in scenarios of major events such as hurricanes. All right, everyone, that brings us to the end of this presentation. Thank you for watching, and I hope this project helped you grow, taking us through a journey of publicly available data provided by the Department of Transportation to find insights regarding major safety events.